Oh, yes. I need your chapter 6 vocab and your signed progress report. Chapter 6 vocab. Your chapter 6 vocab is going to be page 26 of your binder. And then if you got your progress report signed, put it behind your vocab and then pass it to the front. And whenever your vocab is going to be page 26. And then pass your vocab and your progress report to the front. Put your vocab in front of your progress report. And then whenever they pass them to the front, please do not look at their grades. It does only if you have below a 70. No, only if you got it signed.
Dude.
Alright, once you pass your vocab and progress report to the front row needs to pass it to the right. And then you need to get out 6.1 notes, and that's going to be page 27. So put 27 in the top right corner of your 6.1 notes. So vocab is page 26, and then these notes would be page 27. Alright, anyone else need to turn in vocab or their progress report?
Bro, this pencil ain't working.
This is signed.
All over QA. What do you know? Does anybody want the lid I have in there? Yes. There's like 3 pieces in the middle.
Are you guys lid dealing?
Yes. Yep.
Alright, chapter 6, section 6.1 is angles of triangles. First thing we're going to do is talk about how to classify triangles by their sides and by their angles. And you've already done this before back in elementary school, so we're going to do this pretty quickly. Because it should mostly be review. And then we'll spend the most of our time on triangle sum theorem, which you've also discussed in middle school, and then exterior angle theorem. Okay, so like I said, this first part we're going to kind of fly through because it's all review.
What up to your thing?
It was like that when they brought it to me.
I demand a refund.
Alright,
It looks like someone got a hold of it.
what exactly is a triangle? Well, it's a polygon that has 3 sides as well as 3 angles. Okay, now let's talk about the different types of triangles. The first one is a scalene triangle. So over there under definitions for a scalene triangle, you need to write no congruent sides. No congruent sides. No congruent sides means that no sides are the same length. No congruent sides. All 3 sides are different lengths. Sorry. So no congruent sides. Alright, now look over there at those top 3 triangles. Which of those would you say would be scalene?
The first one.
The first one. So you need to label that first triangle a scalene triangle. None of the 3 sides are the same length. Alright, the next type of triangle is an isosceles triangle. So over there under definition of isosceles triangle, you need to write at least 2 congruent sides for isosceles triangle. At least 2 congruent sides.
Wait, but
A
if
triangle
it's
can only have 2
a
sides.
triangle, it has 3 sides, but if it had 3 congruent sides, it wouldn't be an isosceles.
So it would just be.
It would just be.
It says at least 2, means 2 or more.
But
So-
if it had 3
Could be equilateral.
if it had 3 congruent sides, it wouldn't be isosceles.
Would 3 be considered 2, at least 2?
Yes, but
Yeah.
it wouldn't
So
be
it
an
could be
isosceles
both, right?
triangle.
It would be both.
Triangle.
So would 3
It'd
equal
be
so be
equal.
isosceles?
So triangle like the Dorito?
Yes. Alright, so look over there at those. So look at those top 3 triangles. Which of those would you consider
The left two, or the right two, I mean.
The right two. The middle one's isosceles because it has two congruent sides. And then the third one's isosceles because it has three congruent sides. And it has to have at least two to be isosceles. So we have two of them that are isosceles.
Wow.
That's gonna be it because it was.
And then the third kind is equilateral. Equilateral. Equilateral has three congruent sides. So under the definition of equilateral, you would put three congruent sides. And then which of those triangles over there is equilateral?
The right one.
The last one, the third one. So the third one's considered isosceles and equilateral. Now for big ideas math, you're going to want to just pick equilateral. But if you do it on an assignment and you put isosceles and equilateral, that's fine. Or even on a quiz, because it's technically considered an isosceles and an equilateral.
Do you only want one of them though? Like it's okay if you just one?
It's okay if you just put one of them.
Alright.
Alright, the next thing is classifying triangles by angles. And the first one is an acute triangle. An acute triangle has three acute angles. Three acute angles. So over there on the definition, you need to write three acute angles. I would wait till we get there because you've already written down the wrong definition. I wouldn't try to look ahead. There's no way that a triangle could have three obtuse angles. It wouldn't be a triangle.
It would be a circle.
Which of those triangles would you consider acute?
That first one's pretty cute.
The first one's acute. Oh wait, first, what's an acute angle? Less than 90. It's smaller than a right angle. So you said the first one's acute? Are any of the others acute?
No, it's just the first one. Second one's just annoying.
No.
I mean,
It's just the
second
first
one.
one. Second one.
No.
Why not?
Because it ain't beautiful. It's got all them blemishes on it.
Oh my.
okay.
The second one has three.
Yeah, the second one would also be considered acute. What about that last one? Someone said the last one. No, because it doesn't have three. Now, one of the angles is bigger than 90, so that one would not be considered acute.
No.
So only the top two are acute. Alright, a right triangle has one right angle. Only one. A right triangle has one right angle. There's no way it could have two. If it had two, it would not be able to be a triangle.
It'd be a square.
Alright, so a right triangle has one right angle, and the way to tell that it has a right angle, it has that symbol in the corner, showing that it's a right angle, showing it's 90 degrees. Which of those triangles would be considered right?
The third one.
The third one, the one on the bottom left. So you need to label that as right.
I don't know. I haven't met it.
Alright, the third one, the one on the bottom left is right. Alright, obtuse. It has one obtuse angle. Only one. One obtuse angle. What does obtuse mean?
Greater than 90.
Greater than 90. It has an angle that's bigger than a right angle. So you can see here, this angle's bigger than 90. Now your book is wanting you to actually go through with your protractor and measure them all, but we're just going to do it by sight. You can see if a triangle's less than 90 or bigger than 90.
I don't know. What
And
is the pixels
the
on?
way to tell if it's a right angle is if it has the symbol. Okay. Which of those triangles would be obtuse? The bottom right. So label that one obtuse. And then the last one is equiangular. Equiangular. Well, if equilateral means equal sides, equiangular means equal angles. All three angles are congruent. So equiangular, you need to put three congruent angles.
Wow.
And then which of those triangles would be equiangular?
The one that looks like
The second one, the one on the top right, is equiangular and it's acute.
It kind of looks like a baseball field. If a baseball field is a triangle.
Yeah, I agree with that.
Alright, let's do an example. Classify the triangular shape of the support beams in the diagram by its sides and by measuring its angles. Well, I'm not going to actually go through and measure the angles, so we're just going to do it by sight.
That's a triangle.
That's nice.
I'm going.
That's true.
Alright, so on your picture, it might be kind of hard to see, but if you highlight it, this side here is marked congruent to this side over here. So if you need to mark those, you can. Like I said, you can see it a little bit better on the board because it's in color, but so yours might be a little difficult to see. Alright, so by its sides, I look to see how many sides are listed as congruent. Well, 2. So that would be considered isosceles.
That's a weird.
And then it says classify it by measuring its angles. Well, I can see that there's no right angle and none of them look obtuse, so they all look pretty small, so that would be acute. Now, they're not marked congruent, but if I wanted to go through and take a protractor, measure them, and got the same length for all of them, or the same measure, then I would know that it's equiangular. But since I don't have a protractor, I can't say that. And because since they're not marked congruent, I can't say that they're equiangular. The only way I can do that is if they're marked congruent, or if I use a protractor and measure it, and they all come out to be congruent. So we would consider this isosceles and acute.
Would it not be equilateral?
No, this one down here would have to be marked congruent.
Oh, okay, that's crazy. Sorry, I'm a bit dumb today.
Alright, let's try the next one together.
Today?
Classify the triangle by its sides and by measuring its angles. So with its sides, you want to see how many sides are marked congruent. Tyler, how many sides are marked congruent?
2.
How do you know? Yeah, the 2 lines make it congruent. Alright, so since it has 2 lines, or 2 of the sides congruent, Carter, what type of triangle would that be? Isosceles, perfect, yeah, 2 sides means isosceles. And then look at their angles. Nate, what type of, what do you notice about the angles? Yeah, there's this square right here on one of them. What does that mean? I'm sorry, say it again. Yeah, it's a 90-degree angle, which means it's a right angle. So what type of triangle is it? A right triangle. Perfect.
That's a triangle.
You didn't say this is triangle.
Alright, so it's an isosceles right triangle. Alright, what questions do you have for me so far? Like I said, we were going to go through this part kind of quickly because it should be reviewed. Alright, what about this one? Emily, what do you notice about the sides? So what does that mean? They all equal the same length? Alright, so what type of triangle could we call it based on its size? Equilateral? Hey, could I have called it something else?
Oh, yeah.
Yeah, you could have called it isosceles also. Equilateral or isosceles would work.
But what if we just assume that all someone's equal from isosceles?
You could put both. Alright, and now we need to name it by its angles. Alright. Luke, what do you notice about the angles?
The line,
No, the angles, like angle M, L,
they look the same to me.
they look the same? Is there anything they're telling us they're the same?
The line?
No, the lines are talking about the sides, not the angles. Okay, do any of them look obtuse? Do any of them look like they're 90? So they're all smaller than 90, so what type is that? Acute, perfect. So you could call it equilateral acute. Now, you don't know this yet, or you're not supposed to know this yet, but by the base angles theorem, or the corollary to the base angles theorem, if the 2 sides are congruent, then the 2 base angles are congruent, and this is in like section 6.3 or 4. So like these 2 sides are congruent, so that makes these 2 angles congruent. And since these 2 sides are, then these 2 angles are. So on this one, if you would have put equiangular, I would have counted it correct because technically it is. We just haven't discussed that yet. If it's equilateral, it's going to be equiangular. Alright, so like I said, so this one could have multiple names. You could say equiangular, equilateral, isosceles, acute.
No, if it was like something like that, we have to use all three angles.
Are you saying like, do you have to be both names?
Yeah, like that.
No, just one of them. As long as it's one of the right ones, you're good. Alright, chunk 2.
The original.
You're going to need either 2 colored pencils, 2 markers, or 2 pens. If you don't have your own, you can go borrow some of mine, but you need 2 different colors. As long as it's 2 different colors.
Okay. Gray and blue it is.
What language is that?
What? I go like 90 down the highway and the cop will just be jawing my name.
And you have a book.
I never get to that when I drive. I put it on there just to see.
See,
Sir, he actually put the stickers.
Yeah, I think they're gonna be good.
He actually put the stickers
I
there.
don't know.
Or you just
I
like,
don't
he's
think
sure he
so.
was doing it just to like bypass.
So I was driving, right? And it felt really like normal. Now look at it, it says 104 on my
Alright, on chunk 2, for interior angles, first thing I need you to do is write down the definition of interior angles, which is the original angles of a triangle. So over there on teacher notes, under interior angles, you need to write down the original angles of a triangle. No, that part doesn't have to be with the color. Alright, so write down the definition for interior angles, which is the original angles of a triangle.
They were there first.
So if you look over here, this picture looks a tad bit different than yours, but that's okay. I need you to color the interior angles one color. So like here's angle A, here's angle B, and here's angle C. The inside angles are interior, so color those one color. The interior angles, A, B, and C.
This is funny.
Yes. Yeah, on it, Logan.
Alright, then I need you to go to exterior angles and write down the definition for exterior angles.
Whoa, slow down here.
The exterior angles are the angles that form linear pairs with the interior angles. The angles that form linear pairs with the interior angles.
What?
So for exterior,
Triangle's different. He said that. We have to do the same, sorry. You want to?
alright, then I need you to color in the exterior angles with a different color. So notice here for this angle A, if I were to, here's the interior angle in red. The exterior angle is the angle that forms a linear pair. Remember, linear pair means adjacent, they make a straight line, they add up to 180. So then you need to go through and fill in, color all the exterior angles a different color than what you color the interior angles. So when you're finished, it should look something like this. Wow. Okay. So what you're going to do is, knowing that an exterior angle and an interior angle that's right next to each other are a linear pair, they would have to add up to 180. So like if this angle was 60, the exterior would be 120. If this angle was 40, this exterior angle would have to be 140. Alright, So now that we know the difference between interior and exterior, now let's talk about the triangle sum theorem. First, you need to write down what the triangle sum theorem says over there on part A. The triangle sum theorem says the sum, which means to add, of the measures of the interior angles of a triangle is 180 degrees. So if you were to add the measures of all the interior angles, which is 3 of them, you would get 180. So if you were to add A plus B plus C, you would get 180. So write that definition down first over on the left.
You want the formula only with a triangle?
Yep. And then over on the side, right underneath the picture that says triangle sum theorem, you need to write this formula. The measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And this is only the interior. It has nothing to do with the exterior angles or anything outside the triangle. It's just the 3 angles on the inside.
We just did here.
You did this in like middle school.
Yeah, we did this in 8th grade.
I remember we just did like triangles this year.
We've done angles, but not triangles. All right, and then the other theorem we're going to discuss is exterior angle theorem, or just EAT, EAT. First, I'll give you a moment to write down the definition of exterior angle theorem on the left. The measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. So I'll give you a second to write that down over there on the left. And then once you write that down over there underneath the picture, I need you to write this formula. The measure of angle 1, which is the exterior angle over here at C, is equal to the measure of angle A plus B. The measure of angle 1 equals the measure of angle A plus B. Sorry, that was my fault. Give me just a second. Okay. Now, I will show you the reason why. These 2 angles here form a linear pair, which means they have to add up to what? 180. So if this one's 40, what does this one over here have to be?
140, so I can math.
140. It would have to be 140 because they add up to 180. Well, these 2 have to add up to 180. What do all 3 of these have to add up to be? 180. So if this one's 40, these 2, I don't know what they are, but what are they going to have to add up to be? 140, because they all 3 have to add up to 180. Well, if this one's 40, that means these 2 are going to have to add up to be 140 as well. So these 2 have to add up to be 140, and this one's going to have to be 140. So that's where that comes from. These 2 angles added together is going to be the same as this exterior angle over here, opposite, or beside the opposite angle. All right, so let's show you an example. And here I've got 2 teacher models. I've got one with triangle sum theorem and one with with exterior angle theorem. Now, you're going to use these 2 theorems plus theorems that we've talked about in previous chapters, like vertical angle theorem, corresponding angles, alternate interior, alternate exterior, in order to figure out some stuff. Give me just a second. It keeps... There we go. All right, so look at this one. It says find the measure of angle 1, then classify the triangle by its angles. I noticed that all 3 angles are interior angles. So that means I'm going to use the triangle sum theorem, which says all 3 angles add up to 180 degrees. Well, if they all 3 add up to 180, and I only know these 2, I need to see what these 2 add up to, and then see how much I have left. Well, let's see, 78 plus 31. That's 9, that's 10, so that's 109 degrees. So I've got 109, and I need it to add up to 180. So to figure how much I got left, I need to do 180 minus 109. I need to borrow from the 8, 10 minus 9 is 1, 7 minus 0 is 7. So 71 degrees. So the measure of angle 1 is 71 degrees. So that angle right there is 71 degrees. Then I need to classify it. Well, I notice all three angles are less than 90 and none of them are the same. So that would make it an acute. So I have two answers. The measure of angle 1 is 71 degrees. And it's acute. Okay, so another example. Find the measure of the exterior angle. So it's wanting this angle right here. Well, the exterior angle theorem says it's equal to the sum of the two non-adjacent ones. So these two over here. So I would need to use exterior angle theorem. And I would need to add 64 plus 75. 5 plus 4 is 9. 6 plus 7 is 13. Therefore, the measure of angle 2 is 139 degrees.
That's all you gotta do.
That's all you got to do. Now, if it asks me to classify it, I would just need to find the measure of this angle. Well, 180 minus 139 would be 41, and this one would also be acute. But it didn't ask me that, so I'm not going to do it. All right, let's do one together. Find the measure of the indicated angle. So it's this angle here. So my first question, do you think I'm going to use exterior angle theorem or triangle sum theorem?
Exterior.
Interior.
Yeah, the triangle sum theorem, which says they all three add up to what, Randy?
180.
180, perfect. So they add up to 180 degrees. So first I need to see how much is there already. Nate, how would I do that? And what's 130 plus 20? All right, so if these two add up to 150, Tyler, how am I going to figure out how much I got left? What do I need to do? I add 180 plus 150. Gotta subtract them, yeah. So do 180 minus 150. And Alex, what's 180 minus 150?
There's 30.
30 degrees. So this angle down here is 30 degrees. Now, I know I didn't ask this, but let's go ahead and do it anyways. Haley, what type of triangle would that be considered? Why is it obtuse?
Because it has an angle that's larger than 90.
Perfect. It has an angle that's larger than 90, so it's obtuse. Okay. All right, what questions do you have for me so far? Hey, this one's a thinking one. You got to do more than one step. Find the measure of the indicated angle, and it's asking for this exterior angle here. Well, usually to use the exterior angle, I would use the two non-adjacent interior, but it didn't give me this angle here. How could I go about finding the measure of this little angle? Noah?
Use linear pairs.
Yeah, perfect. Use linear pair. So Noah, tell me how to do that.
Oh, 180 minus 137.
Yeah, these two here, this is an exterior angle, which means these two add up to 180. So you would do 180 minus 137. And Noah, what's 180 minus 137?
43.
43? Okay, so that means this angle here is 43 degrees. All right, Dakota, how do I go about finding this measure over here, this angle?
I feel like it's so obvious, but I can't
It is
why.
pretty obvious.
Okay,
Yeah.
is this angle here is an exterior or an interior?
It's an exterior.
So exterior angle theorem says it's equal to the sum of the two non-adjacent interior angles.
Oh, so you just add those two up.
Yeah, so you just add the 43 and the 102. So add 43 plus 102. Drake, what's 43 plus 102?
145.
What'd you say? Say that one more time.
145.
145. Do y'all agree with that?
Yeah.
Perfect. So that's a 145 degree angle right there. Now, whenever you do these, you're going to have to use some knowledge outside of triangle sum theorem and or exterior angle theorem. You could have to use vertical angles, alternate interior, alternate exterior to figure out the missing angle. All right, before you do the two with your partner, what questions do you have for me? All right, go ahead, turn your desk and face your partner. Noah will be there, and you and Daniel will be partners. And then Nate, you're going to be with Logan and Randy.